everybody, and welcome back. In the second part of Spring RDS backend system, uh, if you have gone through the first part of this video series, we understood how we are gonna use the Spring along with the RDS AWS service or AWS cloud database for our cloud setup and database setups. So during that we discussed about the challenges such as imagine your application wants to have a production database, and the production database is a huge schema with multiple tables. Then creating those tables individually or manually is a big challenge. Also also to provision the AWS cloud resources also is a big challenge if you're going to do this manually. So in the first part we saw that with the help of tools such as Liquibase we were able to create the database schema in automatic way. There we need to define the changelog files, correct? And in the second part where we are going to provision the AWS resources with the help of Terraform, that would help us to automate the provisioning of AWS cloud resources in an automatic way. So in the second part we practically gonna run the project. In our previous session we looked at one of the Liquibase repository, and which I have shared in a GitHub project link. This is the project link, you can take a look at it. In this project we were talking about infrastructure provisioning with the help of Terraform. So in this session today we will practically run the project, uh, uh, run the Terraform script, make the RDS instances provisioned on AWS resources, AWS Cloud Console, and then run the Spring Boot application. So before we go ahead with running the Spring Boot application, let's understand how do we configure the Liquibase configuration in our Spring Boot application, and how do we set up the Spring Boot configuration. So the steps are very simple. Let's go to the project. In our build.gradle, under the Liquibase, there we will define the main activities, and in here we provide the URL and the username and the password, correct? And your endpoint would be the one where your RDS is deployed, correct? So let's go ahead and firstly provision the AWS resources. So for that we will simply navigate to infrastructure directory, correct? And therein we will run Terraform plan. First we will generate the Terraform plan. Okay, let me close this terminal and check again. The point here is that instead of manually going to AWS console and creating our AWS resources, it's very good to use the infrastructure as a tool such as Terraform. So before I go ahead and run it, let me take you to my AWS console, and here you can see under, let's go to the home page. Here you can see there is RDS, and under RDS right now you see there are no database instances as of now which I have created. Always there is an option to create the database manually with the help of AWS console, but it's not a good option. It's very time consuming, and it can also become very difficult at times with all the provisioning and other stuffs. So it's better to prepare this with the help of configuration file which we looked at in the previous session. So using Terraform you can configure your network settings, your RDS instance settings, and simply run a CLI command, which you can also automate with many other options such as GitLab CI pipeline and other stuff. But as of now we are not gonna get into those details. We'll simply run it from our local command line and see the changes reflecting on the AWS console. Once the RDS instance is complete, the main thing that is we will run our Spring Boot application, which is already configured with our Liquibase. The Liquibase will automatically generate certain schemas and generate the output and prepare a database schema for our production or any production or development environment. So let's start with first that. Right now I'm in infrastructure directory. I will see if the Terraform version is available. Yeah, Terraform is available. Let's run Terraform. First we'll prepare a plan. So Terraform is simply a infrastructure as a tool, infrastructure as a service, infrastructure as a configuration file, which helps us to create AWS or provision AWS resources in a fairly automated way. So there are a few steps in a Terraform. First is you prepare your configuration file, then do Terraform init, and once the Terraform configuration files are ready, you have to prepare a plan. So once you run the plan, you will see what all changes is going to be applied to your AWS account. So here I can see it's gonna create a MySQL. The plus sign with the green font is indicating that this particular resource called MySQL DB instance or an RDS instance will be created, and other things such as VPCs, public tables, route tables, security groups, which will be accessed via internet gateway, subnets, and all these things which we require for networking will be created. And at the end, it will generate an output which will log as the RDS endpoint. So the plan is there. There are no errors. So I'm going ahead and applying these changes. Terraform applies the command. Once the Terraform, it will ask for a prompt. Say yes. So it will start to create our different AWS resources. Right now it is creating VPC, virtual private network is being created, security groups are being created, route tables are being created, and finally security groups are created, and finally a RDS instance would be spun up. Usually RDS instance takes some time, so it will run it in like 2-3 minutes. So meanwhile we'll go through or revisit the the Liquibase uh, changelog changelog files. So what our initial goal was to create certain database schemas. So here we are going to create an articles table, then we are going to create comments table. Finally, in both these tables, we are going to insert some data using the change set, and the change set has an ID, author, and the change instruction and the column names. So the setup is done. Setup has a basic thing such as your Spring has to know what your endpoint URL is, the username and the password. So right now, if I look at the RDS instance creation, I am adding a DB name as Liquibase app, an admin and an admin 123 as a password. So in the application property also I need to change this to admin. That would be my username, and it would be a admin 123 as the password. And the apply name should be replaced here, and your RDS instant endpoint should be replaced here. So once the RDS instance creation is complete, an endpoint will be generated that will replace it over here. So this is your Spring Boot application property setup. Also, for your Liquibase to run, a few things you need to know is you need to add a Liquibase core dependency as a library to your Gradle build. Then you need to provide a runtime or a Liquibase runtime which is called MySQL connector. Because I'm creating a MySQL RDS instance, I have to provide a Liquibase runtime of MySQL connector, and then you need to configure the Liquibase. So all these things you can find as an instruction on the GitHub repository that I've shared. This one you need plan and apply, or you can set up your build or Gradle settings with the RDS endpoint and your application name, username and password. Then finally, when you want to run the migrations, you will run this Gradle commands. And for your Spring Boot application to connect to the RDS instance, you need to have the Spring Boot properties. Let's wait for a few more minutes. It's already 2 minutes and 2 minutes and 30 seconds elapsed. The instance is yet being created. Meanwhile, let me verify all the configurations are as if there is an endpoint. This endpoint can change, so we'll re-verify once the output is generated. The app name is correct, username and password is correct. All other dependencies are as is. So this runtime dependency is an important thing. If you are creating a MySQL RDS instance, then you need to have a Liquibase runtime as set to MySQL. If you're creating a Postgres instance, then you need to have a Liquibase runtime set to Postgres. That's pretty much simple, and we're gonna create two tables with some sample data. Let's wait for 3 minutes more. Let's look at what the RDS instance that we are trying to create. So here is an RDS in AWS DB instance resource that we want to create, and the resource or the MySQL DB instance is identified by the free tier. Please remember to create a free tier instance if you don't want to incur any additional charges. Then storage is 20 GB, storage type is GBP2, engine is MySQL. We are looking for MySQL engine. Instance class is a micro one which is free tier eligible. The DB instance name are all of these config properties that you want to share. So finally you can see the changes are applied and an RDS endpoint has been generated. So I'll just copy this RDS instance and verify in my property if this is matching. It's matching. And in the build.gradle I'll check if the Liquibase configuration is matching to the endpoint. So this thing is set up and it is complete. Let's do two things. First, we will go back to our AWS console and verify. Let's refresh this, verify if the required RDS instance is present. So here you can see after refreshing the page, this thing is available. A DB identifier called MyDB tie free tier is ready. These are all this information, and you can also check the endpoints available over here. I find this is a endpoint, right? And that is it. Anything else that we can look for is first let's configure how can we connect to this data. Yeah, so the AWS RDS instance is created. Let's now verify if the DB instance is connectable with the help of MySQL Workbench connection. So we will add the host name here. The port is going to be the same. The username is going to be admin, and the schema name is going to be Liquibase app. Correct. And let's test this connection. It's asking for a password. It's going to be admin123. The connection was successful, and we can now AWS RDS instance, MySQL instance. Okay, let's go to this and see if there is any schema present as of now. Ideally, there would be no database schema present as of now because we haven't run the migrations yet, or we haven't run any create table or any create schema scripts manually, which we are going to avoid. We are going to automate the process of DB schema migration with the help of Liquibase. So as of now in this database called Liquibase app, there is no tables or anything present. So next step what we are going to do is we will run the git spring boot project, and we can look at the GitLab or GitHub project instruction. So this is the command. It's a Gradle build tool, so I'm gonna run a dot Gradle w update. This will basically start the Liquibase update process. Here you can see the Liquibase is starting to execute the change log that we have mentioned. And in our previous discussion, we told the change log or the Liquibase maintains two additional table called database change log and a database. Uh, there's one more table called database locking table, which monitors or keeps tracks of all the database changes that are done by different users from different systems. So this command is completed, and we can check the logs. Here we can see it first read the create articles file, and it was having an ID of 1 and the author name is Sandeep, and the table was created. Second change that it read that create articles was completed. Commands create tables YAML file is read with an ID of 2, and it ran successfully. Then it read another file where we basically performing insert operations to add some dummy records to articles and comments table. And finally we can see the run log where 3 Liquibase change sets were run, and this was the current run. It can also show the previous run. So the build for this project was complete. Let's verify if the schemas are successfully migrated. Let's refresh this page. Yes, after refreshing we can see that an articles table is created and a comments table is created, and also we can see the database change log tables which is created. We can look at the content of this table. you select rows, and here we can see there were three file names being added in the database changelog with different 123 IDs that we defined in our changelog file, and it has its own deployment ID. And there is also one more table which takes care of locking the changes. So let's look at the data. Let's look at the data. So here we can see some of the sample data was introduced and added into this table. Let's look at the comment table. We can see sample data being added. So I think this was the end of this, understanding how Liquibase automates the data migration, not the data migration, the database schema migration, and also how Terraform supports provisioning of creating AWS resources in a very easy and automated way. I think this is the right time to end the video. If you have any doubts regarding how Liquibase set up and how the project was built and how Terraform work configuration files have been created, then let me know in the comment section. I will try to add more resources and explain you how the project setup was done. Anyhow, for your reference, you can take a look at this GitLab repo, which I will be adding in the pro video description for your reference. And in the next session, what I'm planning is I will create a new Spring Boot application that would read this RDS table data from our instance, from our AWS console, this instance data, and cache it in our AWS application. It would be an in-memory cache which can be used for our any business applications. So in our next video, I'm targeting to create that topic. So I think we are good for now. Thank you for watching this video, and keep learning.